There is a photograph that exists in no archive, a painting that no museum houses, a memory that no living person carries. But there are clues. There are always clues. They are embedded in the geological record, in the biological record, in the fossil record, and in a scattered body of anomalous evidence that mainstream science has spent considerable effort classifying as coincidence, outlier, or unexplained rather than as components of a coherent picture that, once assembled, describes a world so different from our own that it barely seems continuous with it. We are talking about trees so large that the numbers require a moment to sit with, trees whose trunks measured hundreds of feet in diameter, trees whose canopies reached altitudes that placed them in what we now think of as the lower atmosphere, trees so tall that a raindrop falling through their uppermost branches would not touch the ground for days, filtering down through layer after layer of leaf, bark, branch, and the complex internal weather systems that such a canopy would generate. Trees that, if they existed, would have meant that the water cycle of this planet operated according to entirely different principles than the ones we were taught in school. This is not a fringe claim made by people who have never examined evidence. It is a logical extrapolation from a body of physical data that is harder to explain away than the people doing the explaining would prefer. And it connects directly to one of the most suppressed and most consequential questions in the alternative history community. What actually existed before the world that we inherited? What was Tartaria? And why does the geological record contain evidence of a landscape that should not be possible under the assumptions our civilization has built its entire understanding of prehistory upon? Let us begin with what we can see and touch and measure. Across the American Southwest, across Siberia, across parts of Africa and South America, there are mesas, flat-topped geological formations rising hundreds, and in some cases thousands of feet from the surrounding plains, with sheer vertical sides that have been attributed to millions of years of erosion. The standard explanation is that these formations represent the remnants of elevated plateaus, worn down over geological timescales by wind and water until only the hardest caps remained, protected from erosion by layers of more resistant rock. This explanation is satisfying until you look at the geometry of what remains. The flat tops of the largest mesas are not random remnants. They are, in many cases, almost perfectly circular or oval in cross-section. Their sides descend at angles that, in a surprising number of cases, correspond more closely to the angles you would expect from biological growth than from geological erosion. The silica content of certain mesa formations in the American West is anomalously high in ways that conventional geological explanations have difficulty accounting for. Silica is the mineral that constitutes the cell walls of certain plant structures. It is present in wood, particularly in ancient wood that has undergone specific preservation processes. And it is present in these mesa formations in quantities and distributions that have prompted a small but serious body of researchers to ask whether what we are looking at is not a geological remnant but a biological one. The hypothesis, stated plainly, is this: the mesas of the American Southwest, the buttes, the Inselbergs of Africa, the isolated flat-top mountains of every continent, are the stumps of trees. Not trees as we understand them now, not even the largest sequoias or redwoods, but trees of a scale so different from anything in the current biological record that their existence requires a complete revision of what we understand about the conditions that once prevailed on this planet. Trees whose trunks, measured at the base, ran to thousands of feet across, and trees whose height reached into what is now considered upper atmospheric territory, trees whose root systems penetrated the earth to depths that would have fundamentally altered the hydrology of entire continental regions. Stop and think about what this means for a moment, not as a scientific abstraction, but as a physical reality. If the largest trees on this planet had trunks that measured a mile or more in diameter and reached heights of several miles, then the surface of the earth, as seen from above, would have looked nothing like what we imagine when we think of prehistoric wilderness. There would have been no open sky visible from the ground in the forested regions. The canopy would have been so dense and so elevated that the light reaching the forest floor would have been the attenuated, diffuse light of a deep interior space, not the direct sunlight of an open landscape. The temperature differential between the canopy and the ground would have been enormous. The humidity trapped within the canopy system would have created its own precipitation cycles, its own cloud formation, its own weather entirely separate from the weather occurring at the altitude of the treetops. This is where the water cycle comes in, and this is where the implications become truly radical. The water cycle, as we understand it, operates at a planetary scale. Oceans evaporate. Water vapor rises, cools, condenses into clouds, travels on atmospheric currents, falls as precipitation, runs off into rivers and streams, percolates into groundwater, returns to the oceans. The whole cycle operates over timescales of days to weeks for the atmospheric portion and much longer for the groundwater and oceanic portions. It is a system calibrated to the current surface conditions of the planet, with its mix of ocean, open land, desert, forest, and the particular scale of vegetation that now exists. But introduce trees of the scale we are describing and the entire system reorganizes. Transpiration, the process by which plants release water vapor through their leaves, would operate at a scale orders of magnitude beyond anything in the current biosphere. The canopy of a planet covered with mile-high trees would be releasing water vapor at an altitude equivalent to the current cruising altitude of commercial aircraft. That vapor would not behave the same way as vapor released from modern forest canopies at a few hundred feet. It would enter circulation patterns that do not currently exist. It would create precipitation events at altitudes that are currently above cloud formation level. It would mean that the atmosphere at any given moment contained vastly more water than it does today. And when that water fell as rain, it would not fall through open air to reach the ground directly. It would fall through the canopy, through miles of it, through a biological filtration and retention system of incomprehensible complexity, where every surface it touched would absorb some fraction of it, redirect some fraction of it, hold some fraction of it in the biological tissues of the tree itself, and release the remainder to continue downward. A raindrop entering the top of such a canopy might take days to work its way down through the successive layers of branches, leaves, bark channels, and internal water-conducting tissues before eventually reaching the forest floor. And the forest floor itself under such a canopy would not be the soil we understand. It would be a deep, continuously moist organic layer of extraordinary biological richness, receiving its water not as rainfall but as a slow, constant seepage from above. This is a completely different planet. Not in a science fiction sense, but in terms of every environmental parameter we use to understand what life was and how it worked. Temperature gradients would have been completely different. Atmospheric pressure at ground level would have been higher due to the sheer biological mass above. Oxygen concentration may have been significantly different. The degree to which solar radiation penetrated to ground level, the acoustic environment, the electromagnetic conditions, all of it would have been profoundly different from anything we have experience with. Now ask the question that the alternative history community has been asking for years in various forms with varying degrees of precision. If this world existed, what happened to it? The trees are gone. Not just reduced in size as the sequoias were reduced by logging, but fundamentally gone. The scale of organism we are describing left no living descendants, which means either that the conditions that allowed such organisms to exist no longer prevail, or that something eliminated them, or both. The mesas and buttes that may be their stumps do not show saw cuts or axe marks. They show surfaces that are consistent with having been broken rather than cut, sheared rather than milled, which suggests an event of enormous energy rather than a gradual harvesting process. The Tartaria hypothesis, in its most coherent forms, proposes that the world we inhabit is a reset world, not a world that developed continuously from primitive origins to its current state, but a world dramatically interrupted at some point in the relatively recent past, with the civilization, the ecology, and the physical environment that preceded that interruption either destroyed or so thoroughly disrupted that its remnants are unrecognizable to a civilization that has grown up entirely within the post-interruption period. The giant trees, if they existed, were part of that world. Their stumps, if the mesas are their stumps, are the most visible remaining evidence of how different it was. What would it have meant for human civilization to exist within such a world? The architecture of Tartaria, the buildings attributed to a lost civilization catalogued from old photographs, survey records, and architectural anomalies, makes more sense in the context of a world where enormous biological structures created the primary built environment. The extraordinary ceilings, the vast interior spaces, the acoustic properties noted in many grand buildings of the 19th century that seem engineered for sound environments that did not exist in the cities where those buildings stood. A civilization that developed inside a giant tree world would have lived its entire existence in spaces defined by enormous organic architecture, and its built environment would have carried that spatial memory forward. The suppression of this evidence has followed the pattern that suppression of anomalous claims always follows. Not dramatic censorship, but academic gatekeeping, funding denial, and the slow accumulation of professional cost to researchers willing to take the claims seriously. Researchers who have written about the biological interpretation of Mesa geology have found their work excluded from mainstream publication, not because it has been rigorously refuted, but because its implications are considered too disruptive to the existing consensus to be entertained. This is how paradigms protect themselves, but the evidence does not disappear because the paradigm ignores it. The silica anomalies in the Mesa formations are still there. The geometry of the flat-top structures remains inconsistent with pure erosion models in ways that have not been adequately explained. The fossil record still contains organisms at scales that should not have been viable under current atmospheric and climatic conditions, and accounting for those scales requires either atmospheric conditions very different from today's or biological rules we have not yet understood. The atmospheric data in ancient ice cores still shows oxygen concentrations, pressure signatures, and isotope ratios that point toward historical conditions we have not fully mapped. Consider the Painted Desert, consider Monument Valley, stand at the base of one of those vertical red formations and look up at the flat. Circular top hundreds of feet above you and ask yourself what natural erosion process produces that specific geometry with that specific consistency across that specific landscape. The answer that geology offers is technically plausible but aesthetically incomplete. It accounts for what is there without accounting for why what is there looks so specifically like what remains after something enormous was broken off at the base. Consider the oxygen levels that paleo-atmospheric research has identified in the Carboniferous period, when insect species existed at scales that require oxygen concentrations significantly higher than today's to support their metabolic demands. Dragonflies with wingspans of 2 feet, millipedes 8 feet long. These organisms are not theoretical. They are in the fossil record. Their existence is not disputed. What is disputed is the explanation for the atmospheric conditions that allowed them, and the mainstream explanation that the vast coal-forming forests of the Carboniferous produced oxygen as a byproduct of their photosynthesis in quantities sufficient to raise atmospheric concentration, is itself an acknowledgement that a different vegetative world would have meant a different atmosphere. The question is only how different and how recently. The water cycle of a world with mile-high trees would have been the water cycle of a living planet in a way that our current water cycle is not. The biological mediation of water, its capture, its retention, its slow release, its recycling through tissue and transpiration, would have been the dominant mechanism of planetary hydration rather than the secondary mechanism it currently is. The rivers of such a world would have been fed not primarily by surface runoff but by the slow weeping of an entire planetary canopy. The aquifers would have been charged not by percolating rainwater, but by the root systems of organisms whose depth penetration we cannot currently imagine. We live on the ruins of that world. We live under an open sky that was once a canopy. We stand on plains that were once forest floors. We look at stumps and call them mountains. And the civilization we inherited, the one that began its recorded history in a world already reduced, already post-interruption, already operating under the diminished physical parameters of the reset planet, that civilization never had access to the knowledge of what came before because the transition was too complete, the loss too total, and the institutional interest in maintaining the new consensus too powerful to allow the questions to be asked clearly. But the questions are being asked. The stumps are still there, the silica is still there, the geometry is still there, and the water even now falls through nothing, reaching the ground in seconds, carrying no memory of the journey it once took. If this opened a question you have not been able to close, subscribe and turn on notifications. We go where the evidence points regardless of where the consensus says to stop. Drop a comment with what you think was lost and what you think is still hidden. The conversation is just beginning.